Hello. Today I want to continue with my trend of emphasizing formal logic and philosophy less and discussing maybe high school and middle school mathematics more, algebra, geometry, trigonometry. I don't know if I'll get to calculus. We'll see how it goes. We'll see how this trend goes. I hope that students like it, and I hope that maybe even teachers might tune in also. We're going to present an algebraic proof of the Pythagorean Theorem. And we're going to show that algebra can be a valuable tool to understand geometry. This is a proof that originated in India about a millennia ago, and this was around the time that algebra was really getting its start. The Middle Eastern scholars diffused many ideas. Muslim, Jewish, Christian scholars in Europe took it up. And algebra became an invaluable tool in order to understand, first of all, to develop trigonometry and to further develop trigonometry, to eventually develop calculus, but also to go back to ancient, what we could call geometry. The Pythagorean theorem predates the ancient Greeks by far, okay? But we can actually have a proof of it that's simple and easy to understand. And a lot of you probably never really got a proof of the Pythagorean theorem. You just kind of accepted it. It was something presented to you. Always question everything, okay? In mathematics, it's about the proof, my friends. It's about the proof. Okay, so we're going to prove it. Obviously, the Pythagorean theorem states that if we have a right triangle, the hypotenuse, the length of the hypotenuse is equal to the square root of the base squared plus the height squared, okay? Now, if our base is A, our height is B, and our hypotenuse is C, we would simply say that C is equal to the square root of A squared plus B squared. But we're going to square both sides of that equation, and we're going to present it in the form of C squared is equal to A squared plus B squared, okay? Or A squared plus B squared is equal to C squared. So let's go ahead and do it. I'm going to prove that A squared plus B squared is equal to C squared. Now notice that I have C squared embedded as my area in white here. Okay, it is a square, and I have my C squared. And that's very interesting, okay, because now I have a bigger square that would be, each side would be A plus B. Okay, so I have A here, and I have B, and I have the area of my right triangle. I have my individual right triangle translated each of the four different directions, and I've colored the area in blue. Okay, so you notice I'm proving that A squared plus B squared is equal to C squared. I have my C squared in the middle, but I also have this right triangle translated in a bunch of different ways such that the area altogether would be, okay, in other words, of this whole square, the blue and the white together, I better get my mouse over here so it doesn't go dark on me. The area together would be A plus B all together squared, okay? Now notice what I have. I have A plus B all together, in other words, in parentheses. I have A plus B all together, this whole area here, which would be A plus B squared, is equal to C squared in the middle of it, plus what? What do we have? Why do I have 4 times 1/2 AB in parentheses? Well, note that the area shaded in blue here of this one right triangle would be 1/2 times the base times the height, okay? But I have 4 of them. So I have this whole entire area shaded in blue would be 4 times 1/2 AB, but the area shaded in white would be C squared. Well, the area altogether would be A plus B squared. Now, I've proven that by inspection. In other words, it's more or less kind of a given. You can see it geometrically, but really you can see it intuitively that that's the case. So my next step is going to be to simplify the area in blue here, okay? So instead of 4 times the parentheses 1/2 AB, I just multiply 4 into what's in the parentheses. Well, 4 times 1/2 would be 2, so just 2AB, okay? So A squared plus B I'm sorry, me. A plus B all together squared is equal to C squared plus 2AB. I'm going to simplify. Let's do it this way here. There we go. Okay, I'm going to simplify my A plus B all together squared by making it a binomial times itself. A plus B times A plus B. And that's going to be equal to, again, C squared plus the area shaded in blue, which would be 2AB. Okay, let's just FOIL that, multiply the two binomials together. A, you know from algebra, that's going to be A squared plus 2AB plus B squared. Again, A times A is A squared. A times B is AB. B times A is AB, so you have A squared plus AB plus BA, and then B times B would be B squared. Well, AB plus BA is just, it's the same thing, so you're going to get 2AB. So you have A squared plus 2AB plus B squared is equal to, again, the area shaded in white, C squared, plus the area shaded in blue, 2AB. Well, what do you notice? That's right. The two AB's cancel on both sides. So what we now have is, voila, A squared plus B squared is equal to C squared. And in pencil, I wrote in, I figure, I might as well take the square root of both sides and have C is equal to the square root of A squared plus B squared. But the bottom line is we've proven the Pythagorean theorem using a square and then a square embedded inside of the square. So, that's... A lot of you have accepted the Pythagorean theorem and haven't questioned it, but now you have a very elementary proof using algebra, and knowing what algebra is good for, we can then use it to build on ever greater foundations of knowledge that can eventually take us to the stars. Literally. Thank you.